Happy learning. Let's continue with the CPU scheduling. Earlier we discussed about the basic concepts of scheduling and what are the criteria to choose the scheduling algorithm. Now in this session we will discuss move on to the scheduling algorithms one by one. So what are the algorithms we are going to discuss? First come first serve scheduling algorithm, shortest job first scheduling algorithm, shortest remaining time scheduling algorithm, round robin scheduling, priority scheduling, multi-level queue scheduling and multi-level feedback queue scheduling. Now, before going into them, it's better to analyze and learn some key terms that are involved with the CPU scheduling. Let's discuss one by one. It will be easy to analyze and solve the problems using scheduling. And remember that each process will be represented as either P1, P2, P3 or ABC. Some literals will be assigned to uniquely identify a process. And what is going to be arrival time? Arrival time is time when the process arrives in the system. Literally, it enters into the ready queue. When a process enters into the ready queue, that is said to be the arrival time. And next one is the burst time or execution time. It is the time required by a process to execute on the CPU. What we learned earlier is the CPU burst, the time it takes for the computations and the calculations. That actual time it needs the exact CPU is the burst time. Okay. And next one is the waiting time. So the total time a process sends in a ready queue waiting to get the CPU. So it includes all the waiting periods before each CPU burst. So that means a process may move from running state to waiting state or running state to ready state when there is an interrupt or when there is an IO. So what happens? A process may not get a continuous allocation of CPU to complete its job. So it may have some waiting time in segments. So I have to include all the summation of all the waiting time that it spends in the ready queue. So wait time means you remember it means that it's the process how long it spends in the waiting queue. And turnaround time. Turnaround time is the total time for a process from the moment it arrives in the system until it completes. So it enters into the ready queue. When I'm ready, I've arrived in the, I want the CPU to how long I complete. It includes how long I am waiting, how long I am served by the CPU, and everything it encompasses. So turnaround time, it includes start time to completion. And here in process scheduling, we have one more methodology called Gantt chart. It is a bar chart that illustrates a particular schedule, which includes the start and finish time of each of the participating process. We know that CPU scheduling objective is to minimize the response time and minimize the turnaround time and average waiting time. That is the criteria for your optimization of a scheduling algorithm. So to add that analysis, we are following one timeline graph. This is a timeline representation of each process, how each are allocated with the CPU. So here this 0, 1, 6, 16, 18, 19 or time slots. Normally it will be in the milliseconds. So 0 to 1, the process P2 is allocated. At time period 1, P2 is context switched to ready state and it is and P5 is allocated to CPU or that is running state. So if a process is mentioned in the Gantt chart, that means the process is currently in the running state. That is, it got the CPU burst. So here, this is the time we can have the time domain representation of how the process are scheduled. It is the important visual representation of the concept. And there are some mathematical understandings. So wait time. So how we calculate the wait time? Start time minus arrival time. Arrival time means I am waiting in the ready queue. Start time means I am start my execution in my running queue. So that is the wait time. Where burst time is called as execution time or run time or a CPU burst. It has different naming terminologies. Don't get confused. Burst time, execution time or run time are all same. So how to calculate the turnaround time? It is the sum of burst time plus wait time. Burst time, how long I need the CPU to complete my task plus how long I am waiting in the ready time. In simple, ready queue time plus running queue time, running time. Okay. So these are the key terms we have to remember while we are going through the process scheduling. So let us revise some MCQs based on the concept what we discussed so far. The arrival time of a process is. So what is the arrival time? Options are the moment the process finishes execution, the time the process enters the ready queue, the time the process first uses the CPU, the time spent by the process in IO. So the moment the process finishes execution, it is a completion time, so it cannot be arrival time. We already know arrival means it is related to when the process enters into the ready queue. So the second option is that the time the process enters the ready queue. Yes, when a process enters the ready queue, that means the process is arrived. Third option, the process first uses the CPU. No, there is the first response time. The time spent by the process in IO. So that means I'm in a blocking state. The process in a waiting state. So that's not possible. So the answer will be the time the process enters the ready queue. Next question. Turnaround time refers to option A, time spent only in ready queue. Option B, total time taken from arrival to completion. Option C, only the CPU execution time. Option D, only the waiting time in the system. So time spent only in ready queue, just now we discussed it is the arrival time, so it's not possible to have a turnaround time. Total time from arrival to completion. Yes, we know that. So, when the process arrives, then it will wait for some time, then it get the first response, then again it may wait, then it will complete. So arrival to completion, it's called as the turnaround time. So the correct option. Let's rule out the other option. Only the CPU execution time. CPU execution time is burst time, okay, or run time. It cannot be the turnaround time. Or only the wait time. No, it is called wait time. So the summation of the sum of option C and D, that is the burst time and wait time, that gives the turnaround time. So the option is B. Turnaround time refers to total time taken from arrival to the completion. Next question. A Gantt chart in CPU scheduling is option A, a bar chart showing CPU utilization percentage. Option B, a graphical representation of memory allocation. Option C, a timeline showing start and finish times of processes. Option D, a table containing burst and arrival time. So, first option is about CPU utilization. In Gantt chart, we are only related to scheduling. There is nothing related to utilization. We cannot calculate the CPU utilization here. A graphical representation of memory allocation. No, nowhere we are mentioning the memory allocation of a process. A timeline showing start and finish time of process. Yes, we discussed this Gantt chart. We used to mention the when the process will start execution and when it finishes. So this will be the correct option. So the last option, a table containing burst and arrival time. No, it is not. So the option C is the correct answer. Yes, Gantt chart is a timeline representation that mention start and finish time of processes which are all in the running state. Which metric is calculated as turnaround time minus burst time? We discussed this formula in a different way. How we calculate the turnaround time? We discussed that turnaround time is equals time plus burst time. That is what we discussed. Here they are asked for turnaround time minus burst time. So obviously there will be the answer will be the wait time. Yes, the options are arrival time, wait time, response time, and completion time. So turnaround time is the summation of burst time plus wait time. So the option will be of wait time. Yes. In a Gantt chart, the length of a block representing a process corresponds to arrival time, burst time, turnaround time, or wait time. No, in arrival time, how long I am waiting in the queue? I don't know when it arrives. It is not represented in the Gantt chart. We are mentioning in the table. Burst time is given in the problem. That is what we are taking into the Gantt chart to represent how long the process get executed. That is the correct option. Turnaround time, it encompasses both burst time and wait time. So it cannot be represented in the Gantt chart. Wait time. Yes, wait time is how long it is in the ready queue. That cannot be represented in the Gantt chart. So the option is burst time. In the Gantt chart, the burst time is represented as a block.